Welcome to a new episode of Protocol Explorer. So today I'm joined by two guests. Today we have Andrea and Martin from the Avalanche DevRel team who are going to be talking to us about Teleporter. So Andrea and Martin, if you can both take a quick second, introduce yourselves, tell us what you do, and yeah, tell us what we're going to be working on today.
Cool. So I can go first real quick. So I'm Andrea. I'm part of the DevRel team, as Rahat said. I've been at Ava Labs for over 3.5 years now. And basically our role is trying to make developers' life easier, trying to show the value of the technology, what the technology can do for the developers, and also trying to lower the complexity of getting to build with the technology. So building the academy, building a lot of resources, getting your feedback as a developer to the product team or the developer team so we can actually create tools that are valuable for developers. That's like our whole vision on the DevRel team. So over to you, Martin.
Nice. So I'm with Andrea on the DevRel team, and especially focused on developer education. So what Andrea already mentioned, the Avalanche Academy, we're building that. That's an open, free platform for anyone to join and learn about Avalanche, how to build in Web3, how to utilize the unique features. So it's all there, all for free. So definitely check it out. And we're going to talk about a topic today that we actually have a course there on. It's cross-subnet communication. We will cover what that is in a little bit, but the basic idea is that Avalanche is a multi-chain network, meaning not a single blockchain, but actually a multi-chain network of multiple blockchains. And today we're going to, this has many benefits we can talk about in a minute, but today we're going to talk about how we can interact in between these blockchains and how they can, like call smart contracts on another chain and all this kind of things.
Cool. So the whole that what you just like described there really interests me, of like this multi-chain aspect. And I'd love to like dive a little bit deeper on like what you mean there on that sense. And is a question probably I had in general about Teleporter itself as well. So when you're saying multi-chain, are these like different chains, maybe like layer 2s or layer 3s built on top of Avalanche, or how does that kind of work?
So actually every chain, Avalanche is a network of blockchains, and every blockchain in that network is its own layer 1, right? So the notion of layer 2s or layer 3s is that they're settling down to a layer 1. In Avalanche, all chains are equal and they are all layer 1 blockchains. So not a chain is settling to the C chain or anything. So they're all independent. And this has some benefits. So for example, they are also completely separated, and meaning that if one chain has an issue or anything, then this doesn't affect any other chain. If the gas prices on one chain go up, it doesn't affect any other chain. And this is just of the many benefits we have in multi-chain networks. And there's one more very important benefit, is that it's also virtual machine agnostic, right? Like many chains we see today are EVM chains, but we can also see now more and more ecosystems rising up, right? Like a whole ecosystem around the Move language. Solana is there. Now more and more WASM virtual machines become more popular. So this is all possible within the Avalanche ecosystem, right? Like we see more and more chains with different smart contract engines than the EVM, but also just special purpose virtual machines.
To complement on that, I think something important in the value proposition of Avalanche is, being in the ecosystem. Like sometimes it's like trying to solve all the problems with one single solution, and in fact it's like all the problems has different kind of feature requirements. Everything is in the world, like we want to actually tokenize all the world assets and bring the blockchain technology value to a lot across all different industries. We need to be able to adapt to those needs. And for instance, in the sense of this blockchain, you can customize even the set of validators that are behind that blockchain, making it suitable for compliant use cases, such as institutional use cases that require some KYC process behind, or any not only for optimization, which is really great for that. We have an SDK, Hyper SDK, which can actually achieve a lot of throughput of million of transactions, which is something that we require in the ecosystem if we think that we want to have mass adoption. So it's not only because of the performance, but also because of the customization and being able to fit those requirements that the different industries needs, and not trying to solve every problem with one single tool, but in fact just building the right tool for your use case. So it's just being able to adapt to everything.
So correct me if I'm wrong. So what I'm understanding from this is like, um, within Avalanche, you have an ecosystem of chains, and they're able to, I guess, like, I don't know if this, we'll just use this word, kind of like be modular chains, and like the different aspects of like how they're, maybe the virtual machine they're using. Would that also include like the overall like data availability layers and everything like that as well?
Yeah, I think of a subnet of a set of validators that agree on something. And if we have that broad idea, it's just like you can agree on anything you want. We have, for instance, a subnet that is building a sequencer, a decentralized sequencer for layer twos. So it's just like having a set of computers around the world just agreeing in some state or in some way that you are processing data. So depending on the virtual machine and the structure that you have behind that, you can actually build whatever you want. That's why we also say like build without limits, right? So it's just trying to be able to fit all needs in a set of tools that you already have there to help you build anything.
Yeah, that's right. I think that's a very important point. So there's a lot of flexibility for developers. Many can go with the EVM, right? Like you don't have to come up with everything yourself. You can work off something, but also you can take that and just customize it a little bit. So you take the best out of years of research in the Ethereum ecosystem, and you take the majority of that, but then maybe you add like one or two things, which is really, really hard to do in a single chain system, right? Like if you want to add something to Go Ethereum of the Ethereum client, you have to go through a lengthy process. You have to build support for it in the community. And eventually, if the whole community agrees that this is something that will benefit the entire community, then they will implement it on the chain, right? In Avalanche, you can just take the EVM and then, like make customizations, activate any EIPs ahead of time, right? Like something for zero knowledge or whatever you need on your chain, and then roll with it. Come up with a modular blockchain that can even be permissionless, can be completely public, so it can have a diverse validator set around the world. That is all possible. But yeah, you kind of like have full flexibility, or you can also work off SDKs, what Andrea said, the Hyper SDK, and build custom virtual machines that are much more powerful, that are much more specialized to the specific use case. But what is important is all of these, independent of the virtual machine, all of these chains have the same feature of interoperability. So trustless interoperability within the Avalanche network. Doesn't matter if the blockchain runs on Move, on Solidity, whatever it is, all these blockchains can interact with each other in a trustless manner, and that is really powerful.
Nice. I think there's a good question that came up in this context as well. I think you sort of answered this, but from Sean, do all subnets have to have the same consensus engine?
Yes. For now, this is true. I think there are plans in the future to make this a little bit more flexible, but they do. However, Avalanche consensus is parameterizable. So actually, even within a subnet, you can choose different consensus parameters for different validators. So they might finalize quicker than others. It's probabilistic consensus. So the default setting is set to a probability that is close to 1. Very close to 1, like far, very, very close. And but for certain use cases, you might want to have certain validators that have a different configuration because you want to finalize faster. You don't need like clear to absolute certainty for front end or whatever. And then so there are some it is the same consensus engine, but there are some parameters you may choose for different setups.
And also, I think that once you get to know the Avalanche consensus deeper, is something that you will want to have, because Martin mentioned that briefly about the finality. That is something that you actually desire to be really, really, really fast, because you are interacting with other chains. And if you don't have fast finality, you can have issues or high times when communicating with one chain to another. We can dive deeper into that, how that works or impact cross-chain communication later. But there are also different features that it enables, such as you don't have these incentives to collide with any other pools of validators or any kind of association of validators. So that way you will start, or you won't have these incentives to. I mean, it's better for decentralization, not being not profiting for joining others, but having your own a validator running by your own. So that's something good as well. And the consensus protocol actually enables a lot of things that when you see it in really deep is something that you will want to have.
Got it. Cool. Makes sense so far. Awesome. Then should we take this time maybe to dive into Teleporter?
Absolutely.
Sure
And I
thing.
think to understand Teleporter, I think the first thing is to get a little bit more into the Avalanche architecture, in the sense that we have, when Avalanche was born, let's say, it was born with one chain, that is the P chain, which it basically has every validator ID, every node ID, its signature key. Maybe we can show the slides. Hold on, Martin, do you have them
Yeah,
ready?
yeah. There we go.
Yeah. So those red dots are validators that are just communicating with each others. And if you can go to the one, so that the whole network is called the primary network. You can think that as having a highway, in the sense of like it can accommodate a lot of traffic, a lot of cars in there. But if you have a subset of that validators, it's because it's a subset, it's actually a subnet that it can host its own chain, as we were saying about like having multiple chain architecture. And that second subnet adds to the total throughput of the network with that customization that we were talking about before. So the idea of having those chains is, as we mentioned, already mentioned, is desirable. But the thing is how you keep those connected between each other, right? Because you don't want to have fragmented liquidity. You want to actually have different services interacting with other services that are deployed on another chain. So if you combine all that throughput that you have in the different chains, you have a lot of, and we don't have a limit of how many subnets you can have on Avalanche. So you can have like thousands of chains running in their own environment. And the thing is, when you want to communicate one chain to another chain, you do it via messages. The thing is how you can actually trust that message is coming from the source it says is coming. And so basically you need, in order to activate one thing in the destination chain, you need to prove that something happened in the source chain to trigger the event. That is actually why the finality is so important, right? Because if you trigger some event in the destination, in the source chain, that so if something happened in the source chain that triggers some other event in the destination chain, and that source chain revert or reorg some block or whatever, then, and you already triggered that event in the destination chain, you can have an important issue there. So yes, basically you send a message, you trigger something. Next slide. Yeah.
And I think it's very important, like understanding that if you enable basic messaging, so sending bytes from one chain to another, you unlock all interoperability use cases, right? Like asset bridging, let it be ERC20 tokens, native tokens, NFTs, whatever assets, DAO voting, cross-chain liquidity pools, or whatever you can imagine. If you can send messages, you can do all of this. So I think that's a very important point to point out, right? And now what Andrea talked about is we can just go here, and I think that's what you wanted to talk about, right?
Yeah. Yes, that one. So all the primary network validators validate right now 3 chains. One of those is the P chain, which stores all the VLS public keys of the validators and their staking. So if you want to stake on Avalanche, you need to do that on the P chain, and that is gonna register your own key. And this key is gonna be a key component in the cross-chain communication protocol. But think about the P chain only as a registry. It doesn't store any transaction of the different chains that are in the ecosystem. It's not like a single point where everything is stored, but instead it's just a registry of nodes and signatures. That's everything the P chain is. So that way, so when you want to communicate one chain to another chain, you just need to make sure that the P chain signatures that you have assigned from that message that you receive signed by those who say that are validators, you can actually confirm that signature comes from that set of validators. So you don't need to trust someone that is saying you, these come from these validators, but you actually know what signatures you are looking for in order to actually confirm that message is valid.
I can run through the flow real quick. The beautiful thing is this is all abstracted away from the developers, right? So it starts with we have this AWM relayer, which is an independent entity, an independent application running. So this is completely trustless. Anyone can do it. There's no. It's also permissionless, so anyone can do it. And this one will query the weighted validator set from the source subnet, so the message the subnet where the message originates. Then it gathers signatures from the validators and signs the message, right? So we have a signed message here. And when the verification happens is we just submit it as a transaction, then the destination chain can request the weighted validator set of the P chain, check the signature, and then execute the message. So this is similar to a regular interoperability design you might have between, like Ethereum and any other EVM chain, maybe the Avalanche C chain. But the tricky part is usually these bridges work with a trusted set of bridge nodes, wardens, there are different words for it. And that makes it, like prone to attacks, to security vulnerabilities, because if these bridge nodes, wardens, however you want to call them, are compromised, they can sign messages about things that happened on for example, Ethereum, transmit a message, but maybe the thing on Ethereum never happened. For example, the bridge wardens testify that I deposited $1 million USDC in a bridge contract, and then as a result I would get $1 million USDC on Avalanche, but maybe that never happened, the first step. So now I have $1 million USDC on Avalanche, which I shouldn't have. So this is like a common attack pattern for bridges, tricking these bridge wardens, tricking these bridge validators to testify something that didn't happen. And through this design with the P chain we have here, there are no bridge validators. So the bridge validators are the validators of the source subnet itself. And that is a very powerful design, which just eliminates this attack vector of tricking the bridge validators, which is the most common issue with interoperability in blockchain bridges today. The good thing, you see already, there's a complicated flow here, how this message is transmitted. We have a cross-subnet dApp that talks to teleporter, warp is blah, blah, blah. But the beautiful thing is, for the developer at the end of the day, only two things are important: sending a message and receiving a message, right? Sending the message on the source chain and receiving the message. So everything we just talked about, like signing, like BLS keys and whatever, the developer itself can completely forget about it. And the only thing they will have to do is taking care of the first step and the last step. And in practice, that looks, like the first step, super straightforward, just calling a smart contract called Teleporter Messenger. The function, it has a function, send cross-chain message with some parameters. Which chain do we want to send it to? Which contract on that chain do we want to send it to? Some fees which aren't required gas limit, who are the allowed relayers. And then you can see at the end of the day a message field where we can encode any kind of message, right? And on the other side, what we can do is just implement a very simple interface, which is called receive teleporter message. It has just a single function. So basically, we enable our smart contract on the destination chain to receive a teleporter message, which is super straightforward. And we can see here it has 3 parameters: which chain does the message come from, which smart contract sent it on that chain, and what is the message. That is it. So we can forget about all the complexities here, but what we can understand is teleporter and warp messaging in the Avalanche network does not introduce any third parties that are trusted, that can censor, that can be tricked into something. And it is very, very easy from a developer standpoint to interact with the system. Does that make sense so far?
Yeah, I think so far it's pretty easy to follow. Definitely liking this. It's really cool stuff.
Something important as well is that when you are communicating to chains with the Avalanche warp message, you only send bytes, which make it suitable for any virtual machine to communicate between two different virtual machines. So you actually only need to know how to encode and decode that bytes in order to transmit any kind of message. It's not like teleporter is just a bridge, but you can actually build bridges on top of teleporter, but you can send also any kind of message from one chain to another and trigger different kind of actions. You can actually, and for instance, this what we're showing on the screen is the way that you are encoding two parameters. You're encoding test and 42, and then that becomes bytes. That is what you send in via teleporter to the other chain, and then you decode that, just sending what type of data you're triggering, and that way you can start using those parameters or those data that you are sending as a parameter in another option, in another function on the destination chain, trigger different actions, and just do that thing. And something important is that the relayer is the one that is in charge of covering that gas that needs to be first covered by the transactions sent on the source chain. So that way, when you say what kind of gas am I paying for this kind of transaction, is you need only to incentivize the relayer, and the relayer takes it's in charge of paying for the gas on the destination chain. We will see how those parameters are coded in once we see the code. But yeah, it's basically you just incentivize the relayer to do this thing and just deploy one contract on the destination chain, one contract on the source chain, and the encoding and decoding path that you need to follow.
Awesome. So I think we can start looking at some code if you guys are ready. Are there any questions before that, or how do you guys feel?
I think we're good so far on the outside questions, but one question maybe on my side. So from architectural perspective, everything looks cool and makes sense. In terms of like when I guess you're interacting with multiple chains, doing some bridging or anything, what does like time to finality for like a cross chain transaction or message kind of like look like? I know like generally chains in the ecosystem are pretty fast, but like when you're kind of like going from chain to chain, how does that finality work?
So it's basically submitting one transaction on the source chain, and the finality on each chain is practically instant finality. So you'd submit a transaction, and once the network process that transaction, is already final. So it's just under a second. Then the relayer pick that message, and it depends on the relayer basically on how fast it picks the message, and it takes another transaction on the destination chain to execute that. So it's just really quick how you can actually do that, because you can trust that you can trigger the second action on the destination chain without waiting for some sort of confirmation, because you already know the transaction in the source chain is already final. So yeah, it's in seconds you can have your transactions being triggered in the destination chain.
Yeah, so what we just saw the question here too. Basically 800 milliseconds on the source chain, sometime for the relayer, let's say very pessimistically 1 second, and then one transaction confirmation on the destination chain. So I'd say like in a pessimistic case, we should be like around 3 seconds.
Nice. I would say the pessimistic case looks much better than most optimistic cases on other roles. So
that is true, yes. Amazing. Okay, so what I will just show real quick is how people can start playing around with it. So there's something it's called Avalanche Starter Kit, and you can find it with Google. It's a GitHub repository, so people can just go there. And the beautiful thing is you can start playing around with Teleporter and Avalanche tooling without installing anything on any kind of computer that just has access to an internet browser. And you can do it by going to code here. Usually now there's a big green button called create code space on main here. Since I already have some, it doesn't show anymore. But if you go here, make sure that you're in the code spaces tab and then click on create code space on main, or if you already have some on the plus here. And then what happens is that we open up a cloud development environment hosted by GitHub. This is completely for free. And what happens now in the background is that we're basically building from a containerized setup with all the dependencies you need. So there's Avalanche CLI in there to spin up a local Avalanche network. There's Foundry in there for smart contract development and a few other tools. And yeah, you can follow the logs. This will probably take a minute or two. So we don't have to wait. Or Andrea already did this, I think, and she can share her screen, and then we can jump right in, so we don't have to wait all the way.
Yeah, I already have it here. Okay, cool. So what you will find when you open this code space is first a Foundry file for configuring all the networks. We will be spinning up a new local subnet, and let's first see our contracts. You will have different contracts here that you can check out for different interactions with Teleporter. So we'll check.
Can you zoom in just a little bit?
Sure. Is it better
there
now?
We go. Much better now.
Yeah,
Thank you.
It's much better.
Great. So in source, you will find different examples of code that you will find. As we said, there is a receiver contract and the sender contract. Something important to know is that if you want to create like both ways communication, you can implement the receiver and the sender in the same contract and deploy that contract in the two chains. So it doesn't need to be a sender and a receiver, but it can actually be one single contract for both chains. It's just a matter of abstracting the complexity and breaking that apart so it's clear for you to understand where the messages are being sent, where they are received, and it's just more about like an education process that you can follow here. So if we see the sender, this is sending a message from the C chain to your subnet. Let me zoom out a little bit because it's hold on. Okay, never mind. So if you see here, there is a teleporter message. This is a contract. When you deploy your own chain, and this is a contract also available on C chain, you will have this contract that is interacting with the precompile of Avalanche Web Messaging, which handles all the signatures, communication with the nodes, and that kind of thing, and verification of the actual message. So what you are doing here is calling this contract that is already deployed on the C chain and will be deployed on your subnet. Actually, let's create the subnet so you see you get familiar with that process. So inside this container, we have Avalanche CLI, which is a tool that will allow us to create subnets really easily and start just creating that right away. So to create a new subnet, you just need to go Avalanche subnet create my subnet, the name of your subnet, and this will prompt you what. Oh, sorry. I already created this. So Avalanche subnet delete my subnet. So we start from scratch. Okay, Avalanche create my subnet, and this will prompt you a wizard to select the virtual machine that your subnet will be running. In this case, we will be running the subnet EVM. We will be using the latest version of the nodes, and this will give us prompt us to add a chain ID. This is a chain ID, EVM chain ID. This needs to be unique for any other chain ID. So one way to actually get a unique chain ID is to go to chainlist.org, and in here, if you include testnets, you can just search with Control F one random number, and if that is not picked by anyone, you can just use this number. This is a protection mechanism for EVMs to protect against replay attacks. So we can just put that in here. And the token symbol, we can put test. And here's where you configure the gas, some gas configuration about how many throughput you're willing to take each block, how many disks you will be using. And so right now we're gonna be going for the C chain settings, which is low disk usage and low throughput as well. And when we create a new chain, we need to specify the genesis block as well, with the different distribution of tokens at the very beginning. So if you want to do a quick test, you can use these default ewok addresses that you should not use in production because the private key is all over the place. So please never use this option in production. But you can also customize your airdrop on the Genesis with this option. But for now, let's go with this ewok. And here is what, if you remember what Martin said about taking the EVM and just modifying different things, activating different features, this is where you can do it. This is called via precompile, which is basically modifying different components of the EVM to add this extra functionality. But for now, we're not adding anything because we're going to be focusing in Teleporter. So no, we're not using a precompile here. Oh, is it working? I don't know what's going on. Okay, let me cancel this because I think my computer is pressing. Can you let me? Oh, it's restarting. Hold on. Don't know what happened. Okay.
Yeah, but I think to point out what just happened, right? Like, so Andrea is able with a few CLI commands to create a configuration for a custom EVM chain, right? Like, so you don't have to fork Go Ethereum, go in there. So you can just with a few simple CLI commands create a configuration of an Ethereum EVM chain, but you can tweak with just simple configuration, like what we just saw. She can create her own token. She can set the chain ID, and all this is super powerful. And you will see in a minute when the configuration is done, it's just as easy to deploy than the blockchain with it, right? Like she can just with one command deploy the blockchain, which will spin up a local Avalanche network. So this is not on testnet. This is obviously not on mainnet. With everything we need from there. And then we can also play around with it in this local test environment, right? Like, so this Avalanche starter kit really helps you to get started with Avalanche quickly, to understand the concept of like this multi-chain network where you can create your own chain, and then like go ahead and just play around with it a little bit. All right, so as we see now, we're creating their own token. So this is kind of like what ETH is to Ethereum, or AVAX is to the Avalanche C chain. Test will be to your, and this is actually super powerful for subnets to have their own gas token. So think about it. You can have a blockchain where gas is paid in the token you define. So you're no longer subject to, like there's an NFT drop happening on Ethereum. Suddenly transactions cost 50 times as much, right? Like, this will not affect your own blockchain. If you have a DeFi application running on your own blockchain, like we have, for example, Dexalot, which is running on a subnet. Through the like, I'm sure many people remember the times of inscriptions, like where a single DEX swap, even on layer 2s or something, costs $10, right? We don't even want to talk about Ethereum. The Dexalot exchange was completely, like didn't even notice, right? Like, because they had their own gas token, they weren't affected by this. Traffic on one chain, fee spikes on one chain don't affect another chain. So awesome.
Cool. So now that my computer it's back, it asks you if you want to enable Teleporter on your virtual machine, which means just deploying that contracts that we are gonna be using when we interact with Teleporter. And if we want to have an Avalanche or messaging relayer for this, we say yes. And now that we have the configuration ready, we need to deploy it. So Avalanche subnet deploy my subnet. And it asks us where we want to deploy. We're going to go for local deployment right now. And what this is doing is spinning up 5 nodes in our code space that are running their own client app, Avalanche Go. It will give us 5 RPC endpoints that we can connect to this network, and it's deploying. Again, I already launched this, so I need to clean my network. Avalanche network clean. And now again, it's saying I already deployed that because yes, I did. But now that it's clean, it will work, so we can go through the whole process again together. So yeah, this is spinning the 5 nodes with the virtual machine that we create. This virtual machine is going to be configured with the Genesis information that we provide. It's gonna be having the precompile that we activate, or in this case, we didn't activate any. And we'll launch these 2 chains, the C chain and our subnet, with the teleporter contracts activated. So right now, these are the addresses that are being assigned to our chains. We have some node 1 running on the port 9650, and we have, as we said, 5 nodes here running on localhost for our code space. Whenever if you're running in a code space, you will be prompted this as well. It's the code space node endpoint. If you want to access from outside, let's say from your wallet or anything, you want to access this network, you will need to use this RPC endpoint and open this port, the port that you want to connect, which you just need to right click it here, port visibility, going public. And that way you will be able to connect your wallet to this local network inside the container, and use this endpoint that is actually pointing to this port inside the container. If you decide in some way to deploy this in a local environment, not inside a container, you can just use localhost instead. So now that we have the chain deployed, we can see our contracts on Teleporter, and we also have the registry. This registry just keeps the version, is kind of a version controlling mechanism for Teleporter to be upgradable and to always be, it's like security measurement that the team took for anything related to Teleporter versioning. You will also have an account funded, which is the one that the evoke account, and you will have the private key as well. This is the one that you should never, ever use in production. And you will have the configuration of your chain here. So with this, you will have the possibility of start coding your own contracts. And what we are doing now is just sending a message from C chain to our subnet. And what this can be is any kind of message, as we were saying, but think about any service that is integrated in C chain, such as, I don't know, like VRF functions of Chainlink, or any interaction that is already there, or just like getting a message to trigger another action. So right now, what we need to do is building this contract. So we point to this contract, our teleporter messenger. We're not using the registry just for simplicity here, but we are just pointing straight to the contract that we have deployed. We can just check the address matches because it's a full new deployment. But yeah, it gets assigned the first one. So we have that, and then we have to implement the send cross-chain message to the messenger, which is pointing to the teleporter. So that's everything we need to do, is just implement this send cross-chain message function from our teleporter to actually be able to send the message. And what we do here is just wrap everything in our application function, which is send message, and we're deciding or inputting the message that we're sending in here, which is going to be a string. We're going to be sending the word hello, and we're sending this. Of course, we need to specify where are we sending this message, right? So right now we only have the vision of the C chain, and we need to specify which chain we are sending this to. We're changing this in a minute, but this is going to be the chain ID assigned on the P chain. It's not the chain ID that we assign as an EVM chain for replay attack protection, but it's actually when you deploy a new chain on Avalanche, it is a transaction committed to the P chain, that is specified or assigns a new chain ID, blockchain ID, to that specific subnet. So to get these chain ID, we need to interact with a precompile that we have available. And if you go through the README, we already did this. And what we need to do, something important.
Actually, I
is,
think you can also use Avalanche subnet describe nowadays. They just put it
oh,
in
really?
the recent. Yeah.
Let me see. Avalanche subnet describe my subnet. Let's see. Mhm. Okay, teleporter.
And then a little bit further. There we
Local
go.
address. Yeah, local. Yeah, so this
And
one,
then
right?
yes.
Okay.
So why do we have two blockchain IDs? The EVM chain ID, as you already saw with Chainlist, isn't necessarily unique. Anyone spinning up an EVM chain ID can freely choose their EVM chain. So it doesn't really identify a chain. Like if I was in a good mood, I could just pick, like the same EVM chain ID as the Ethereum network. Obviously, me sending a message from my chain doesn't carry the same weight as a message originating from Ethereum, right? So so that's why this you can see it's much longer because there are many more chains. And so you can see that works.
Yeah,
Andrea, I think in
so
line 8 you have the one import committed out. That's why
yeah,
inline.
sorry, I don't know what happened. Okay, cool.
No worries.
Yeah, so we specify which chain ID we are using here. If not, you can also call, if you configure your Foundry, because we are using Foundry to interact with this chain. If you configure my subnet here, so our nodes have something with that allow you to put an alias to a specific chain. So if you have that, because we are using Avalanche CLI, you can just call this by the name that you gave to the subnet instead of using the whole chain ID. So if you add this to your endpoints in Foundry, we can start interacting with that. So another way to get these chain ID, that blockchain ID, is through this call to this specific address. This address in a specific is a precompile that will give you that information. So if we call that, we can see this matches the one that we have here. So that way we're saying, send this message to this specific blockchain. And with that, we need also to specify which contract are we interacting with, like the receiver contract. This is going to be something that we will put as a parameter, because we need that as when we deploy the contract, then we can pass it here. And here is where, you remember, we talked a little bit about the fees. So when you start, when you are going to send a message, as I said, you need to incentivize the relayer. And how you are doing that is incentivizing that relayer via an ERC20 on the source chain. So imagine incentivizing with USDC or any other token on the C chain, in this case, because we are sending from C chain. And you put the address here and the amount that you are granting that relayer for transmitting the message. And you also specify the gas limit. This is important because the relayer will be granted with this fee if he or like if the relayer send the message on the destination chain with at least this amount of gas. This is because you want the message to have at least this destination, this gas on destination to execute properly, or at least that's what you think, right? The gas requirement that you are expecting. And then you have this other parameter that can define which relayers are allowed to send that message. And this can be for any business reasons that you might want to have. Probably you have an agreement with someone that say, like, if you transmit my messages, I will incentivize you, but I will block, so you can be the only one that transmit that message. Or if you are the only one that are just, if you are hosting your own relayer, you can put your address here and just restrict for you to be the one that is sending that messages. And here is the important thing: what message are you sending? So in this case, and as we saw in the presentation, we need to encode the message. So this is transforming bytes to be transmitted to the other chain. So now that we have that, let's see the receiver. So the receiver is basically in the same sense that you need to call this same contract now on the destination chain. And if we see here, we will see we have on my subnet, we have the same address, which is nice. And you will have to implement the receive the receive teleporter message. And this message is going to have what you need to do once you receive the message. So because you're receiving this message and this implement, this is inherited by the interface itself. It's not like you are modifying any other thing, but you are just calling this function of the receiver. And what we have here is that you receive this message. As you can see, this is bytes that is coming from the relayer that is sending this. And behind this, teleporter makes sure all the signatures on Avalanche Word Message are being called, are being verified, and everything is good. So you as a developer, you only need to implement this interface. We are just checking that the sender is actually the teleporter the teleporter on the other side. And what we do here is we decode as a string the message, and then we will have that message stored in this variable called last message. So if there are not any question here, we can go ahead and deploy our contracts on the different chains. So what we will be doing now is we're going to be using these forge create commands on our local C. Local C, as I said, you are not only, when you use Avalanche CLI, you don't only deploy your subnet, but you deploy also an instance of the C chain and the P chain and all, like the primary network. So with this, we are going to be deploying the sender contract on C chain. And this will give us an address that we deploy to, which is this one, as a sender. And as a receiver, we also deploy this, but now we're going to be deploying on my subnet. Oh my God. We're going to be deploying on my subnet, and this will give us again an address, which is the contract that is being deployed to. And now let's send the message. So to send a message, we need to, and I will be put it down here so we can modify this command accordingly. So we put here, we have the private key store in our variables in the container, so you won't be, you don't need to worry about that. So we're interacting with this contract, which is a sender contract, which is the first that I deploy to the sender contract. And we are interacting with this specific function, which is a function that wraps the teleporter send message function. And with these two parameters, which are the ones that we need to provide, which is the destination address of the contract that we are interacting of the receiver and the message that we are sending. So we need to modify the receiver contract as well, which is deployed to, and the message that we are sending, which is hello. And what we do, and we're interacting on the local C, okay, because we are sending from C chain to my subnet. We send this, and we have the transaction information. And now to actually confirm that we actually have this variable stored. Oh, it's loading. What's going on? Okay, we can just call and see what is the value of that variable. And this is the receiver contract, right? This is a receiver on my subnet. We just call this function, and we should see hello there. So hello. And so we actually send that message to a brand new chain, store the value in a new variable from interacting with the C chain. So that's basically the complete flow of doing that. Of course, you can actually start sending round trips. For instance, here, whenever you receive a new message, let me show you a little, like super quick, how you receive a message, and in the same function, you are sending a new message back. So you can start creating like complete flows of communication. You can send, for instance, you have here different concatenating messages. You can have different functions activated, and that's all. You can deep dive into this in the academy. In the academy, you will see how you can trigger different actions, how you can customize the different encoding and decoding settings from receiver and sender, and you can start playing around different functionalities and start creating on top of that, interacting with the registry, creating even your own bridge, your own minter of tokens. That kind of stuff is something that you can start looking in the academy and get really deep into what's going on with Teleporter.
Yeah, I think just to wrap up, so what happened, right? Like Andrea spun up the code space here. She was able to spin up her own blockchain just in a few moments. So this is your own EVM chain running with your own gas token. May implement your own staking logic, right? Like similar, like your own blockchain, layer 1 blockchain. It's not settling anywhere. You have control over it. You can also make it permissionless, any validator set. And then just with calling a smart contract and implementing an interface, a Solidity interface on the destination chain, she was able to communicate between these two blockchains. So this opens up a lot of possibilities, right? Like for many blockchain applications that are thinking about today launching, like on Ethereum or even on the Avalanche seed chain, right? So many use cases are not possible in blockchain today because a transaction can't even cost 20 cents, right? Like this is like a highly optimized smart contract interaction. But, like if you do social media, imagine paying every time you post something 20 cents. Like not many people can afford this, especially if we look like in the global context, not like the US, Europe, but like everywhere. And I think like looking at this can be a very, very powerful tool for many, hopefully for many new applications that can really unlock different things there.
Yeah, I think the fact that you're able to even just do all that on this live stream, just go through all that, is just a testament to like how, this makes just like all of this a lot easier to do. I really love the fact that, just on this call, we were just able to see like an actual interaction between a couple of chains just like work. So that I think has been one of my favorite parts of this entirely. Like within the hour, we show kind of like the foundations of like building some of this stuff, which is really, really dope. We have one question also that came up here. Is there a fee market for relayer services, or how are they incentivized?
Yeah, that's a very, very good question. Do you want to take it, Andrea?
Yeah, so they are incentivized by the application, and in this line that I show you here, this is where you put the incentives. Right now, that the relayer that we have configured in the code space takes any kind of messages regardless of the fee. But it's super easy actually to run your own relayer. We have some containers ready, so you can just deploy that and start like running your own relayer. If not, it's just like it's a matter of the incentives. So the thing is, if you are asking the relayer to submit this amount of gas on the destination chain, and that has some sort of price in the market, this amount of gas on the destination chain, then the fee that you need to be incentivized, and it should be at least that fee, right? So the relayer doesn't have that cost on their own. So that is the minimum fee that you need to provide to an external relayer. But I mean, if you want to run your own relayer, it's really easy, and it's not gonna be you won't need to incentivize an extra fee for them to relay that message.
And it's very important, unless you can see here also in line 28, right, that's allowed relay addresses. The dApp developer has the option to restrict which relayers can relay the message, but they don't have to. So if they don't, or if they specify multiple addresses, it's a first come, first serve, right? Like, so whichever relayer delivers the message first can claim the reward if there is a reward attached to it, right? So this really opens up, like anyone can just relay their own messages. Or out of convenience, this can be implemented in a wallet. Or if people are like out of convenience, like I don't want to run my own relayer, so then I will attach a fee. And they can even, like attach a small fee and increase it later if there's no relayer picking it up or whatever. But this should all be abstracted away from the user. And especially like bridging to your blockchain should be very easy for you because you have control over the gas token. It basically doesn't cost you anything, and that's what many applications do. They will let users send messages to their blockchain for entirely free and charge only for the messages going out back to the seed chain, because that's the only thing that actually costs something for these blockchains.
Nice. Awesome. Cool. So for folks who are tuning in, if you do have any other questions, make sure to drop them in chat. Went through quite a lot of bit of information, so I'll leave it open a little bit for there. Just a question for both of you in terms of like for folks who want to get started, learning more about this, like beyond the scope of this, live stream, would the academy be the best place to kind of like go into that?
Yeah, absolutely. The Academy is a great resource. It not only has the information about Teleporter, but it also has some Avalanche fundamental courses that you can take. Even if you're not a developer, in that specific course, we don't get a lot into the code itself, but more the fundamental. It's still technical course, but it shows you and talks a lot about the architecture, how what virtual machines are. Probably that's something that you have heard in the space a lot, but you're not quite sure what that means. You can get into that, get a sense of a lot of blockchain fundamentals and Avalanche fundamentals as well. But yeah, you have there and a teleporter course as well. So yeah. I think Martin's gonna share something. Yeah.
Yeah, can you guys still hear me?
Yes.
Yep.
So yeah, this is the Academy page, right? And there are a bunch of courses here: Avalanche Fundamentals, Subnet Architecture, and then Cross Subnet Depths with Teleporter. That's really the course where people can learn a lot about Teleporter interoperability. And then there's even one more on customizing the EVM, which is a little bit more advanced. But yeah, these are definitely the courses.
And if you have any feedback on those, please let us know. We're improving each day. So we also have some support channel on Telegram for the Academy students, so you don't need to be alone by your own studying. So yeah, we can help with any question that you might encounter.
Awesome. So I think we're at time. But is there anything else that the two of you would want to mention just before we wrap up?
I just want to thank you a lot for the time. Oh, go for it, Martin.
The only thing before we say thank you and goodbye is we have also an accelerator program. So if you're thinking about building something in the Web3 space and any of these technologies just appeal to you, and a consumer use case that wouldn't be possible on Ethereum because it's too high gas fees or anything, then definitely reach out to us. We have an accelerator called Codebase. It's twice a year. The first cohort is running right now. The second cohort will come sometime later this year. It's a $50,000 stipend for every team that gets accepted, so no equity that they have to give up. It's just a stipend, and then it's a 10-week program, and we'll take them through the whole process, technical assistance, but also financial support. So that would be huge.
Nice. Awesome.
And also to participate in different hackathons that we are running every time. So be aware, it's a great space for you to connect with other developers, with other product persons that are you might be looking for join your team. So yeah, just be active in the community, and yeah, that's the last thing I want to say. So
you're talking about community. We have a brand new Avalanche ambassador DAO actually. So
yeah.
that is a huge community, like people that are just entering the space or in the space looking for opportunities globally. Feel free to check out Avalanche Ambassador DAO. Lots of community events. They can get funding for community events or any kind of projects coming from the ecosystem. So I think these are the best places to start. Academy, if you already have a team, if you want to build a project already, Codebase, if you're just a builder or just a community member that's curious about the tech, join the Ambassador DAO. Yeah, just start in your local community.
Awesome. Cool. Well, thank you for both for being on the stream. It's been awesome to learn quite a bit about the Avalanche ecosystem from both of you, as well as just learning about Teleporter, and really enjoyed the overview that you guys gave. So thank you both on that end. And for folks tuning in, we'll be announcing the next episode later next week. Next week, actually, we will not have another episode of Protocol Explorer. We'll be actually out, but we'll be continuing the week after. So look out for announcements on that end. And if you're tuning in, make sure to also join our Telegram group, which will be linked in the comments below. So thank you all.
Thank you so
Thanks a
much.
lot for having us.